All right, section 3.4, looking at mathematical proof of number theorem, or I'm sorry, to number theory. And so in this case right here, we're really just kind of establishing some baseline things that are going to possibly pop up later. We're not actually doing any proofs. So that's kind of a fun reprieve, I think, if you ask me. So GCD or GCF, however you want to call it. Remember that with GCD or GCF, the idea is that we're looking for the greatest common divisor. So we take our 18 and our 27 and we list out the factors, right? So that's it's generally called the greatest common factor. So 1 and 18 and 2 and 9 and 3 and 6. 4 doesn't go, 5 doesn't go, so those are our factors of 18. We do the same thing with 27. So 1 and 27. 2 doesn't go into 27. 3 and 9. 4 doesn't go into 27. 5 doesn't go into 27. 6 doesn't go into 27. 7 doesn't go into 27. 8 doesn't go into 27. I'm back around at 9. So those are my factors. So now the greatest common divisor of these two, the largest one that will work, is going to be 9, because that's the one that comes out of each one. All right, on the next set, so we list those out. We have 8 and 15. So we list out the factors, 1 and 8, 2 and 4, and 3 is the only number in the middle, so we're good to go. On the next one, it's 1 and 15, and 2 doesn't go, but 3 and 5 does go, 4 doesn't go. So in this particular case, we're looking at this guy and we're like, oh, wait a second. 2 and 3, nope. 4, nope, nope. So our greatest common factor is 1. Well, if that's the case, then these numbers are called relatively prime, which we'll get into in just a minute. All right, so let's keep looking at this guy and see what happens here. All right, so got my pen, clear screen. All right, so in this particular case, our first example is going to be, when we're looking at relatively prime, is the one we just looked at. And so that's that situation where we have the 8 and the 15, like we just saw. So let's take a look at another one. So two numbers are called relatively prime if their greatest common factor is equal to 1. So in this guy, we do 3 and 5. We know the factors of 3 and 5 are 1 and 3. The factors of 5 are 1 and 5. So the GCD is 1. We do 28 and 33. So 28 is going to be 1 and 28, 2 and 14. 3 doesn't go, 4 goes 7 times, 5 doesn't go, 6 doesn't go. So now we do 33. So we get 1 and 33. 2 doesn't go, so we get 3 and 11. 4 doesn't go, 5 doesn't go, 6 doesn't go, 7 doesn't go, 8 doesn't go, 9 doesn't go, 10 doesn't go. We're back at 11. So once again, our GCD of these two guys is 1. So that is relatively prime. All right, so I'm going to stop this video right there. So that takes care of the conversation about relatively prime and GCD.